I'd like to keep these so we can have also the description, which will help us understand as well some of the things. So what are we trying to do is, okay, so we're trying to create the following tables that are basically the answer to this diagram, the transformation, I mean the mapping of this diagram to relations. Now, doing so, we are going to we took some decisions. For example, if we go back here, you see the student number and SSN, both of them are underlined, which means they are potential primary keys, and we decided to choose one of them to be the primary key. But these ones also need to be unique, so we need to add that. And then we have this decode major, decode minor, because there are two relationships between the student and the department, and we this end up having two foreign keys. And then we have the rest. Let's just take it step by step. We'll start with the student and then keep going. So first of all, we need to create a database for our new schema for our new set of tables. So I'm just going to create schema and give it a name. I told you that you have to use your S full ID and then whatever name you want. Well, then what you should do. I don't have this restriction, so I'm just going to call it university. I then need to use the university, and then I will create the table. So the table is student, and open parentheses, close it, and then in between I'm going to just do one thing to make it easy on me. I'm just going to copy those. Of course, I'm not going to use the same, but just this is going to help me get the names. So the student number, this is the first one. What is data type? I'm just going to make it int, and this is my primary key. Then I have the SSN. The SSN of the what? Put the size of the int. Do I have to put the size? No, I don't. Well, do you know it? Do you know it? What's the size of that? I mean, do you have any information either from here or from here? So if you want to put something, put it, but I don't have to, because nothing is mentioned, so I'm just going to keep it open. But if, for example, it tells you somewhere that the student student number is maximum 10 digits or 5 or whatever, then you put that. But because we don't have any information, so let's not put any restriction. The SSN, though, do we have any information about how it is? It's just a number, so it could be a number. Same thing, I'm just going to make it an int. However, this SSN should be unique. So I just would like to do that. By the way, this hash key means these are comments. That's why you see it like that. But I'm going just to go and I will add the constraint right now, so don't forget it. So the constraint is, I'm going to call it unique on the SSN, and it's unique and SSN. Okay, what else? I mean, this is something that is unique, but it could be also not null, because normally I don't want this to be empty, so this should be not null. Okay, the class is a varchar. Why is it a varchar? Because if I look here, the class says it's either freshman, sophomore, or graduate. So actually, it makes more sense to put as a varchar, because this is how they said it's going to be. So what is the maximum? I don't know. You can just count what is the biggest, but we don't know. For some, I'm just going to make it 50, and not null. The sex, it should be varchar as well. Do we have any information how it's stored? No. It could be varchar 1, for example, to be either M or F, right? But then if I want it to be varchar like this and not null, or maybe I can use a default, because maybe the default value is going to be M, so I can use M, for example. which is default value, and if nothing is given to us, if otherwise not mentioned. But I can also put some kind of restriction. I can check that the sex, put this between parentheses, is either equal to M or the sex is equal to F. So I'm accepting only these two values. Or if I'd like to also accept the capital, lowercase, whatever, I can just also put the capital or whatever. But I'll just accept M capital or F capital. If something else is given, I'm not going to accept it. So this is something that I'm adding. I'm just adding these things for you to know, but there's nothing that specifies how this is stored. Maybe you could choose sex to be 0 or 1. 0 means something, 1 means something. I'm just doing things just to show you different ways how you can put some checks, how you can put some constraints of uniqueness or not null or default values. So the birth date is a date, and okay, no need to put this. Not null or wherever. I'm not going to put not null everywhere, but you could put not null everywhere if you want them to always be there. So for here, for example, just this, I'm going to put not null 50. Same thing for the middle initial. Middle name, it's not middle initial. Middle name, let's say varchar, and then not null. And these are something that I would like to put as not null. Then the street address, where it should be something bigger. It does not have to be not null. I don't know, 150. Then the city is another varchar, whatever. State, same thing. Zip is generally a number that have some kind of, maybe have how many digits. If I know exactly how many, this should be 5 probably, but if so, okay. The C phone, this a phone number. A phone number, is it an int? It could be an int though, but with an int you miss the leading 0 or the plus with the country code. But it could be an int, and then you just put everything there. But it's up to you. I'm going to put it as int just to make a change. Is it mandatory? Well, it's up to, again, there's no. This is the correspondence phone, and this is the permanent phone, if I remember, the P phone and C for correspondence, address and correspondence, whatever. So they just make it. If I know exactly how many, I can put how many, but just put it as the int. I don't mind. Or you can put also as a varchar if you would like to put some parentheses. I don't know how you would like to store that. The address, I'm just going to do the same. The primary key, can we make the primary key not null? Actually, yes, but by default I think it's not null. But I think it could be null though. It could be null. So yeah, you could make it not null, true. But I'm thinking I think by default primary keys should not be null. But if you just mention it, I don't think it's. Well, it doesn't seem to be a problem, but I don't think it is going to be a problem. Then the P phone is the same. If we just be consistent, if you use int, just be int. The degree program, I'm going to use a varchar as well. And then these two, the decode major and the decode minor, these two are some code of. These are foreign keys that are going to be onto this decode. So this decode, is it a number or is it a? There's nothing that tells us that what is the decode. Do we have the department code is nothing that tells us what it is. So we could make it a number. So I'm just going to make it as an int, and same thing with the other one as an int. Now these two, they need to be foreign keys, right? So I'm just going to make the constraint, which is going to call it FK Frankie from, I mean, you don't need to say from, I know where I am from student, but it's going to be for department. Frankie to department, but then I have two Frankies. Well, this one, maybe let's say for the major, and the other one for the minor. So for the major, then I'm going to say it's Frankie. What is the column that is the foreign key is this one, and it references, well, now I need to say department. I'm just look at because I put everything lowercase, so just I'm going to respect the same, or is it? I put it capital, but anyway, I'm going to put lowercase or put them capital S, so it will be the same. I just would like to be consistent. Department, and then in department I'm going to call it decode because that's the name that I'm going to use, right? So I have two of these because I have one for the major and another one for the minor, and this one is for the major. For the minor is going to be the same thing, except that this one is going to be for the minor, and it all references the same thing. What does this mean? I have these two that references the same thing. Why is it complaining? Oh, constraint. Thank you. So I was missing an S. So then I have two of these. That means what I'm saying is that this column, I'm not going to accept any value unless it exists in this column in this table. I can have another column in the same table that is also need to be exactly the same, one of the values that exist already in this column in this table. So that's okay. And that is a table student, but I cannot run it because if I run it, of course, it's not going to work. I'm telling that I'm looking for something. Okay, hold on. Let me just clear this so I can see the error message. There was another one that was there. First of all, I have create schema university or this database already exists. So what I can do is I can just create schema if not exists. So if it exists, I'm not going to create it. So now if I run, this one is going to be, well, cannot create because university, but it's not a mistake, it just keeps going. So use university was alright, and then create table, I had a problem. Cannot add foreign key constraint. Well, it's normal because it references a table that doesn't exist. So before doing this, I need now to create the table department. And this table department, I have these columns that I'm just going to copy and paste again. So this is the decode, which is an int and the primary key, and then I have the dname, which is a varchar. I'm going to put 50. It should not be null. And then the college, well, maybe it does not be null as well. And then the office, I don't know, just, and then the department phone. Let's be consistent and make it an int. Okay, let me save this. Okay, so this is week 6 exercise number 2. So now if I run this, it's going to be not working because it tells me you have an error, check this. Okay, so I cannot see the error message on this one, but I just would like to show you that there's some help that this tries to give me. See, it tells you where the problem started. You see, if it's not really clear, but you can see that it says check the manual that corresponds to your MySQL. All right, write syntax near the comma, and then there's not null dphone. So you see, starting from here, this parenthesis, starting from it was a problem. So it tells you with the dphone. So it's now it tries to help you to find out, I mean, which line actually starts, the problem has started. So actually this is our problem. Now if I run again, inshallah, it should be fine. Both of them, create table for department, create table for students, both were green, which is great. Now the problem, if I try to run again, I can't because table department already exists. So what I'm going to do, I'm going to just prepare a statement in case I would like to make a change just to drop all the tables and then create them again. But the drop table, I'm going to add also if exists, because maybe it doesn't exist and I'm trying to drop it. I need to follow a sequence, because if I try to now delete the student and then delete the department, I have a problem, because you cannot drop. Actually, the opposite is the problem. Yes, I wanted to do the opposite and then I did the right thing. So if I try to drop the department before dropping the student, because the department is used by student, then this is not going to be allowed. So you just need to put the right sequence. So I did the yes. I mean, it depends on what is your last and what is your first. So what you need to delete first are the ones that are using others. So, and what you need to create first are the ones that are needed by others. So you have, like, when you create, you use the base class, the base tables first, and then those other tables that are needing those tables obviously need to be next. If they are not connected to each other, then you don't have to care about the order. Anything will make sense. But you have some tables that are needing other tables because they're linked to them. Then you have to delete the tables that are, like, using the others before being able to delete the tables. Yes.
Can we use create table if not exist instead of dropping?
Create table if not exist. Well, I can do that, but still, if it exists, it will not create it. So if you make a change and you'd like to apply that change, the change is not going to be executed at all. You have to drop it again. So you still have to drop it. But yeah, you can create table if it not exists. So I can do something like this. So if it doesn't exist, then you create it. But if it exists, you don't want to create it, fine. You can do that too. So now if I run, this is going to work all the time. There's another thing that I can do if I don't want to care about this, and especially because maybe you don't want to care about those, you can just drop the whole schema if it exists. So now, because I can drop the whole schema, which means it just drops all the tables. I don't need to care about drop tables anymore, because drop schema drops everything. So I drop the schema and then create it again, which means now this just deletes the whole thing. Now I'll have this university should be in the bottom. I created use. Normally it should be bold, but it doesn't show it. So anyways, that's the idea. You can drop the schema, or you can drop the individual tables. Well, I would like to drop the individual tables, so you can pay attention to the sequence. So I'm going to leave this here so you can have it, but make it as a comment, line comment. So the next thing is the course, and I'm just going to create table course that is going to use. Of course, I can also do this if not exist, so just to be consistent. And then in the course we have these things, and then the decode. So the course has to be dropped after the code. So I'm just going to be a little bit quicker. This is int primary key, and this is varchar. Maybe let me copy this. So this is varchar 15.null. The description, well, maybe just varchar and 150. The semester hours, this should be some, maybe an int, I don't know. The level, you see the level seems to show as blue, maybe because this is some kind of a keyword. So just not to make any changes, I can just use these oblique single quotes. But it maybe it works without. But I don't want to think about it. So what is the level, for example, of a course? I need to go back here and see each course a level, but there's nothing that mentions what kind of things. Course number. The value course number is. Where is the level? Where can I find the level? Name, description, course number, number of semester hours, level. So maybe it's level 1, 2, 3, 4, 5, 6, 7, 8, whatever number, or maybe it's sophomore. exactly. So I'm just going to just use it as an int. I don't care about it. And the department code, it's very important because department code is my foreign key. I need to use exactly the same data type. Now, when I say the same data type, I also mean the same size of the data type. For example, if I'm doing this, I'm saying that this department, the decode is out of 5. And then in here, you see, I did not mention that's 5. If I try to run this thing, it's going to tell me there's a problem. Let me just comment this so it doesn't be part of the problem, because we're not even going to reach this anyways. But let's run. As soon as I'm trying to, oh, okay.
They have different name.
No, I'm talking about here. This should have, I was expecting this to fail, but maybe because the size is bigger than the other. And if I just, for example, make this to be 4, I hope that it's not going to fail. Yes. You have an error in your blah blah 4. Why is it 4 is the problem? Because the int, I can have int just 2, for example, in the department code. I did work, and I kind of not happy with seeing it working. Before, in the previous version, it's not acceptable. It has to be the same data type, same size. But with the int, it seems like it's something different now, which is kind of weird, because I'm specifying a different size and yet this is a foreign key. Yeah, it still be accepted. But anyways, but it has to be the same data type, obviously. If I use this to be a double, well, I hope this is going to be a problem. And it is. So it doesn't tell you exactly what's the problem, but it has to be the same data type. It used to be before in previous versions of MySQL, it used even these different sizes are not accepted, but now it seems maybe they're giving more flexibility. No, I don't think it's about that too, because it's not about put something that can be put in others, because this is a value, you see, that I need to put that need to exist from other values. For example, if I put this to be 5 or 3, I'm accepting only 3 numbers, 3 digits in the decode, and here I'm accepting a lot. But because I think why it doesn't matter, because if you put 100 as a number, or maybe 1000, which is having 4 digits, because it's an int, the restriction is not going to be a problem, because it needs to check if it exists already here. I was even thinking that, okay, maybe if I have 1000 and then I limit here to 5, or maybe to 2 digits, I was expecting this to fail as well, but it didn't. It was also accepting that. So anyways, for this it doesn't matter, but maybe if you change another data type, if you make it varchar, for example, of course this varchar, and it's an int, there's going to be a difference in data types, so it's not going to be acceptable. So they have to be the same data type. Before it had to be the same name. If I do this, for example, make this varchar, and this should be varchar, and this is kind of weird because we tried it earlier. If it's a different size now, for this one, it will fail. No, it doesn't. Well, it used to, but now it doesn't. So, which is weird. Well, obviously if it's like this, but of course if it's a completely different data type, it's going to fail. Like if it's int, and now the other one is a varchar, so if I run this, it's going to fail. But the size doesn't matter, it seems. So the size doesn't matter as long as the data type is the same. And what is remaining, so the level we set int, the decode, it has to be an int, and then I'm just going to copy this, and foreign key, now it's going to be department, and I don't need this. The decode is the name in my table, and a department code. Do we have any other things for the course? So if I drag to drop the course, it has to be before department. So what about student? Can it be before or after? It doesn't matter. So you can put it after the student or before the student. It doesn't matter at all. So, but it should be before. It should be dropped before the department. That's what's important. Now the last ones, this section is kind of nice. So I have a section because it uses the course number and the section number. These are new ones, and all these are the primary key. So I'm just going to create the table. I'm sorry? This one? Well, this section is a weak entity, so all these three are the key, but it also needs the key from the course, because the course is what identifies this weak entity. So I'm going to use the C number as a foreign key here and part of the primary key. So just if not exist, and I'm going to use this C number again, but it's not going to be my primary key because the primary key is much more complex than that. So int is cnum, and then actually I'm just going to add the constraint before I forget it. This constraint is about the foreign key, because this cnum is going to be about the course. So the foreign key pointing to the course, and the cnum is going to be the course cnum. And the primary key, there's another one.
The name of the table will be course.
It should be a section. Then what else? I just come here. I just need to copy the others. So we have then the section number, which is an int, and they all should be not null. I can just put this not null, but they are going to be part of the primary key, so they could be, maybe I'm going to make it int and not null. And the year, because it's blue, I'm just not taking any changes. It's going to be an int and int 4, and I can put the year to be like a condition. Check that the year is not going to be negative. That's the least that I can do. It should be greater than 0, or maybe it should also be not less than something else, but at least it should be positive. And then the instructor is varchar. I'm just going to do it like this. Then I need the primary key constraint. The primary key is, what is my primary key? All these four together. I'm just going to copy it from here. So these four are all part of my primary key, and I have a constraint which is a foreign key, and that's it. Right? Anything else? Yes.
How is it possible that we have more than one primary key?
We don't have more than one primary key. We have only one primary key, but this primary key is composed of many columns, which means I can have, let me show you, okay?
The column is not the same as attribute.
Well, it is an attribute, but let's say, for example, if you put the course number 1 and section number 1, semester number 1 in year 39, for example. So this whole thing is a primary key, which means this whole thing cannot change. But I can have the same course with the same section in this time the second semester of 39, right? But I can have also the same course, the same section, the same semester. It's the first semester, but then in 40. But what I cannot have is exactly the same, again, all four together be repeating. And that's what these all four together being a primary key means. Each one of them individually can change, can repeat. But can I have all of them repeat at the same time? No, that's not what is not possible. So it's still one primary key, but it is composed of more than one column, one attribute. So I always have one primary key in the table, always one. So now if I run this thing just to make sure that it works, it just keeps going, and then I need to add the section. Now the section needs to be before the course, right? So it can be with the student, it doesn't matter before or after, but it should be before the course. All right. Now the grade is a very simple table. I'm just going to create a table. Grade. Just trying to be as fast as possible. if not exists, and then this numeric grade is my int that is going to be my primary key, and this letter grade is just one letter, or it could be two maybe. Varchar, if it's a b c, it's one letter. Okay, if you look at the question, does it mention it's yes, so this one letter, so that's great. So I'll just varchar 1, and then I can also make sure that it's not null, and I can also check that this letter grade is going to be either A or B, C, D, E, and F. A, B, C, D, or F. Yes. This one equal. I just got the Java distraction. So yeah, this is what I've checked, and then that's it. Why is it complaining? I have not closed the table. All right. So that's the table grade, and if I drop it, it does not relate to any of them. It could be the first one, it could be the last one, it doesn't matter. Grade. Now the last one, which is a fantastic table, the stud section. You see it has the student number coming from student, this all 4 coming from section, and numeric grade coming from grade. So let's do that. Let's copy this, and this one is kind of interesting because it's possible, but that's not the right thing to do, because if you don't have a primary key, then how can you identify it uniquely in one of the records? But sometimes you have that type of table, and then it's not going to check for you if there's any repetition on specific columns. But technically it's possible. But you don't do that very often. You do that in very special cases. One of those cases, if you'd like to, for example, to save some just in information that is just one line of information, you don't need to have many. So, but it's a really special case. So the student number is a number. I'm just going to make it an int, and then I have the course number is another int, and then the section number is an int. The semester was an int. The year was also like int 4 maximum, and then the numeric grade was another int. And this is the table. I'm just going to make the primary key, which is all these things together. I'm just going to copy them. This is my primary key. And just to, and then I need now the foreign keys. I have how many foreign keys? But how many foreign keys? I have 1, 2, and 3. 3 foreign keys. Not 6. Because if you put them individually, these are not going to be checked together. Because, let me maybe give you an example. But before the example is just create the constraint. This one is for the student. The student, the foreign key is student number, and it references the student. I should have copied maybe this one, or no, it doesn't. Okay, it doesn't exist. The student, and then it's student num. Is it the same? I just need to make sure it's the same name. Yes. So this is my the first one. The other one was like for the course. No, not the course. The grade. I want to leave the last one for last. Now this last one, this is about the grade. which is this numeric grade, it references the grade, numeric grade, right? It's the same. Now the last one, because if you pay attention to this, right? Now the student section is the result of 3 entities connected together, right? So these 3 entities, I have a foreign key coming from grade, a foreign key coming from student, and a foreign key coming from student, so from a section. Now this section, it has a primary key composed of these 4. So that's why the foreign key that I'm going to have is going to be composed of the 4. This is about the section. And why they have to be all 4 together? Because if I just put them separately, it means that when I'm going to check just separately if they exist. But why is this a problem? Let me, just before I forget, just copy this again. This is what my foreign key is going to be looking at. First of all, just would like to run to make sure that it works. I don't want to see a red line. It is a red. So why is this a problem? Section, it says near section, okay, because the name here is a problem, and this should be, if I'd like to use the same name, I should use this oblique single quotes. Let's run again. Hopefully no problems. It still have a problem, but so what is the problem again? You have an error statement next to student number. So near student number, where is the student number? So here, starting from here, I have a problem. So why is that? You see student number, CNUM, and actually I need to be careful because it's not this one, because after the student number there's an int and I'm not seeing an int.
81.
So you see it's this one here. I have a red line here because I forgot maybe a comma. Okay, let's run again. There's another error. Where is it? So 85. Oh, but why is it 85? Maybe at the bottom I have another comma, and let me just maybe put this back here so I can see it. Subhanallah. Yeah. Yes, you had a question? Okay. So let's run now. Hopefully no more. So it's good. It works out. So now let's just understand what happened. But before that, I need to drop this table. So if I need to drop this table should be the first one to be dropped, or at least because before this, because it uses all of them, many of those actually. So drop table, this one, if it exists, and then so this is going to drop them all. But I just would like to mention, like I did here as an example, why I want to check not individually, why I did not put each one of them a separate constraint, one for the course number, one for the section number, and the section number. Actually, if I do one for the section number, I need to use all these 4 anyways. So I cannot have like this section number connected to what? To this. But this is part of the primary key. The primary key is the whole thing, not just part of it. Because even though, let me show you what happens. Now maybe a student, now this table is going to be having, let me just take this section here, student section. If I know, I'm interested in this. So now if I put some values in here, okay, the values that I'm going to put are the student number, 3211 whatever, this is the ID, the course number. I'm just, for clarification, I'm just going to make some course code. My course number is cs350, just because I would like you just to make sense of the data and not put a lot of one. So the section is 102, and then the semester is 40, and then the year, the semester is 1, and the year is 40, because this is where 401, and in that year you got the numeric grade of 1. But again, numeric grade is a number that is associated to a letter. So 1 is A, 2 is B, for example, something like that.
You said it's like
No, what I said is mentioned here. You see, the numeric grade and the retrograde. So 0 for F, 1 for D, etc. So 4 is for A. So let's just use the same thing. So if I do something like this, I would like to have an A. That means that student, he got an A in this course in this semester. So if I just copy and paste another, there's another student, or maybe the same, he got in another course 120, I don't know, in section 101, in that same semester, whatever, he got another A. But what I need to check is that I need to check that this number that I'm entering here should exist in the table student. What I need to check is this letter that I'm putting here should exist in the table grade. But this is the combination that I'm looking for that should exist. Because maybe this exists. If I look only in the course, based on the course table, not in the whole sequence, maybe there was this course exists in my list of courses. But were there a section of that course taught at this semester? Maybe it wasn't. So that's why we want them all together. We want to know that this section of this course of this semester of this year, it existed. So that's why we want all these together, not just individually checking that the values are correct. We want to know that all of these happen to become together first. So that's why we have to put these 4 together. And actually, these 4 together come as a primary key from the section. So this is another indication that they come all 4 together. But this is the first time when we see something like this. Is that okay, inshallah? So it's kind of fancy. We'll, inshallah, next week we will start entering some values, and we will be able to see these kind of, when I'm trying to insert some values that are existing individually in the tables, like the course, and then but not in the combination of these, then it will not allow us to enter, and then we understand that why this is making sense. The midterm is going to be about this. The midterm is going to be, I'm just showing you some diagram and tell you, okay, draw some tables based on this. For example, I can show you this and tell you, okay, from this diagram, okay, draw this. I'll show you only this part because it's not going to be the whole thing. I'm just part of it. For example, I'll show you just part of this, and I tell you, okay, draw from student, department, and course, for example, or maybe department, course, section, and grade, whatever. So it's just going to be from this. You have to read the cardinality ratios and understand where are going to be the foreign keys are going to be, and then you create the tables. And what you're going to be giving me is this, a file like this, which creates the tables based on the entity relation diagram that I showed you. And so you have to do the step of mapping the entity diagram to this kind of relations. So you have to do this separately, but I'm not interested in it. Which one? Oh, here. You have to do this separately, and then you have to convert this to your create table statements.